Okay, so we are now learning about scheduling problems. We now look at how we can use activity networks to determine the overall minimum time. That's very important. The overall minimum time required to complete a project. Let's again consider making a cup of coffee from the previous lesson. So what we're going to do here is we're going to use our precedence table and our activity network here to determine the overall minimum time required to make this cup of coffee. Okay, what we're going to do first is something called a forward scan. So can I get you to write down forward scan, forward scan. And the whole point of a forward scan is to help us find something called the EST, which stands for the earliest start time. So our forward scan is going to help us find the earliest start time, and we tend to like to use a green pen to do this. So if you've got a green pen, grab it out. Okay, so we're going to do something called the forward scan. Now, before we do that and before we use our green pen, we start always at time 0. So I'm going to do that in a blue pen. We're always starting at time 0, all right, always. Then we're going to say, all right, then I've got activity A here. And activity A is filling a kettle. Now, filling a kettle takes 10 seconds. So that means I'm going to put a 10 here. Now, this right here, I don't want you to write this in, otherwise it will become messy. But this right here is my EST for activity B. Now, don't write that in because it will get a bit messy. But that 10 there is my earliest starting time for activity B. Now, what does that mean? What it means is you need to wait 10 seconds before you can start activity B, because it takes 10 seconds to fill the kettle. And you can't start activity B until you fill the kettle, because you can't boil the water unless the kettle is filled. So that means there is a necessary wait time of 10 seconds before you can start activity B. So what we say is the earliest start time for activity B is 10 seconds. All right, I'm going to rub that out. Now, I'm then going to take this earliest start time for activity B, and I'm going to go 10 plus 300 is going to give me 310. So the time that I finish activity B is going to be 310 seconds. Now, before we do anything, let's come back to the start because I haven't considered this pathway. So this pathway is C, which is putting coffee in the cup. So that's going to take 5 seconds. So that means my earliest start time for activity D is going to be 5 seconds because it takes 5 seconds to do activity C, and I'm waiting on activity C to be done before I can start activity D. Now, 5 plus 5 is 10. Meaning, it takes 10 seconds for me to get to this point right here because 5 plus 5 is 10. Now comes the tricky part. Let's zoom in here. What do you think that's a very ugly 310. Can I try that again? 310, and this is 10. Now, here comes the tricky part. Can you tell me, what is going to be my earliest start time for activity E? Is it going to be 310 or 10? Which one is it going to be? Now, hopefully you can recognize that it's going to be 310, so I want you to circle it. It's going to be 310, and the reason why it's going to be 310 is because it takes 300 seconds, or in other words, 310 seconds all up for A and B to be done. It takes 310 seconds in total for A and B to be done. So even though we can finish this in 10 seconds, we need to wait until the longer one is finished before we can proceed. So that means our earliest start time for E has to be 310. It always has to be the bigger number because we're always waiting on the bigger number to be done before we can proceed. So whenever you're in a situation where you've got two edges coming to a vertex, your earliest start time is always going to be the bigger number because it's kind of always restrained by the bigger number. We're still waiting here. So I want you to picture something for a second. I want you to picture the fact that you've done this first step here. You've got to 10 seconds. You've put coffee in the cup. You've put milk in the cup. You're done in 10 seconds. But now you still have to wait another 300 seconds until, the water is boiled. So that means the earliest start time for E has to be 310. That's why we've circled it. Okay, E was pour water into the cup. So once the water is boiled, we can now pour water into the cup. That means we're going to go 310 plus 5 is 315. This 315 is telling me, and I'm going to write it in again, but don't you write it in, otherwise your page will become very messy, so don't write this in. This is saying that the earliest start time for activity F is 3:15. So only after 315 seconds can we start our next one. So let's rub that out. 315 plus 3 is going to be 318. Okay, so this will be 318. That is going to be, now this is important, this is going to be the overall minimum time to complete it. The overall minimum time is going to be 318 seconds. So that means overall, the time required for you to complete this project in the minimum time is 318 seconds. And we've achieved this by doing our forward scan, by finding our earliest start time to all of the activities there. All right, that is the first part there. So hopefully that's made sense. Let's now go on to the next part, which is going to be a backward scan.